Welcome to the first episode of the Hyper Casual series. In this one we're gonna set up the player movement. So, let's go! First of all, we need to create the Unity project and choose a specific version of Unity. For this one I chose 2020.3 and I highly recommend that you choose the same one or a higher version. And for the template we're gonna choose 3D Core. Then just choose a name and the location of your project and wait for it to load. The next step is to import the Path Creator asset. So let's go to the Unity Asset Store and type in Path Creator into the search box. If you're having trouble finding it, you can also enable the Free Assets filter. Then just open the Bezier Path Creator by Sebastian Lag and press Open in Unity. The package manager should pop up, and once you see it, just press Download first and then Import. Once that's done, you should see a Path Creator folder. Now open it and go into the Scenes folder. Once you're there, open the road scene, and in here you should see a nice example of a road. We're gonna use something similar. So let's select the Road Creator object and copy it. Now let's go back into our initial scene and paste it here. You should see that we have a Road Creator and a Road Mesh Holder object now. In order to clean up the hierarchy, let's create an empty road object and place these two underneath that one. Now let's select the Road Creator and take a look at it. You'll see that we have multiple red spheres which represent the nodes. Now let's delete them until we have only two left. We can do that by holding down Ctrl and clicking on them. Now let's make a straight road. Select the first node and set all the positions and the angle to 0. Now let's select the second node and set the X and Y position to 0 and the Z position to 10. Also don't forget to reset the angle to 0. But as you can see, the road is still a bit tilted, and that's because we haven't reset the Road Creator transform, so let's do that now. Alright, great. Now that this is done, let's take a quick minute to explore what other options we have with this asset. First of all, we can add and remove nodes, also we can change their position and rotation. We might need a longer road, so let's change the second node's Z position to 50 instead of 10. The second option that we have is changing the global angle of the entire path, in case you want to make a tilted path. Next up, we can change the road width, which is self-explanatory, and for this game we're gonna go with a value of 1.5. We can also change the thickness of a road, which is capped at 0.5, but later I'm gonna show you how we can unlock this value and make it even thicker. Alright, that's the basic part. We will go into more details as we progress. But for now, let's continue by creating the player object. So let's create an empty game object, reset its position, and call it player. In order to add some temporary visuals to our player, let's create a capsule as its child object. And next, let's raise its Y position to 1 so it doesn't look like it goes underneath the road. And voila, we have our player. Now it's time to move forward. But first, let's change the position of the camera a bit so we can see the movement better. I'm gonna move it a bit forward and up, and change the rotation on the X so that the camera looks down a bit. Now let's select the player object, press Add Component and type in Path Follower. Inside the Path Creator field we need to drag in the path that we want the player to follow. So let's drag the Path Creator object from our scene. We can also select the End Path instructions. Loop means that once the player finishes the path, he will go back to the beginning and start again. Reverse just means that he'll switch directions. And stop means that the player will just stop at the finish line. And also we can adjust the speed to control how quickly the player moves. For now, let's leave it like this, press play and see what happens. Okay, so we got two issues. First of all, the player started moving from the wrong point, and secondly, the rotation. The first problem actually happened because we mixed up the finish and the starting point. To fix the issue, let's go back into the editor, select the waypoint that's far away and drag it a bit back. Now let's select the point that's at the beginning and change its Z position to 50. Now finally we can select the first point and change its Z position to 0. Alright, now I'm gonna increase the speed to 20, press play and see what happens. As you can see, the direction of the movement is fixed now. In the future we're gonna expose the index of the waypoints so we don't mix them up anymore. Okay, now let's exit play mode and open the path follower script to fix the rotation problem. The code responsible for the rotation of a player is down in the update method. As you can see in the path creator asset, there is an entire method called getRotationAtDistance. We could try to tweak the method, but a much safer way would be to just add a rotation of 90 degrees on the z-axis. So that's exactly what we're gonna do. We're gonna access the transform's Euler angles and add to them a new vector 3 with coordinates 0, 0 and 90. And if you press play now, you'll see that the player is facing the right direction, so the problem has been solved. Now that our player can move forward, the only thing left to do is to add the ability to move left and right. So let's create a folder for our scripts, and inside of it create a C# script called player movement. When you have it ready, select the player object and attach the script onto it. Then open it up and let's finally start coding. First, let's clean up the script and then let's create an update function. In here, we're going to check if the left mouse key is pressed. If that is the case, we're going to move the player. And for this purpose, let's create another private void called movePlayer. We're going to call this function in the if statement above. The purpose of this function will be to calculate the x position where the player needs to be and move him there. Now let's get back into Unity and open the game view. But before we proceed, we actually need to change the platform to Android from the build settings. And while we're at it, let's also change the compression method to LZ4HC. This will ensure that our application will be well compressed, but don't pay too much attention to it right now. When you're done, just hit switch platform. This will take a bit of time, but when it's done, let's go back into the game view and pick a resolution that makes our screen actually look like a smartphone. For this game I picked 1920 by 1080 portrait, but you can pick any screen size, landscape or portrait, doesn't matter. Then depending on the position of the mouse or the finger, we will change the X position of our capsule. To make it clearer for visual learners, let's take a look at this sketch. Let's consider we're playing on a smartphone which is 1920 by 1080. We will create a certain parameter that will have a value of -1 when our finger is all the way to the left, and a value of 1 when your finger is all the way to the right. And when our finger will be exactly in the middle, this value will be equal to 0. Depending on this value, we will change the X position of our player. So, let's see how we can implement this in our code. First, we're going to make a local float variable. Then we're going to make it equal to the X coordinate of the mouse position for now. And if we take a look at our sketch, we need to remember that when our finger is all the way to the left, the X position of the mouse will be equal to 0, and when it's on the right, it's going to be equal to 1080. And when it's right in the middle, it's going to be exactly half of the screen width, so in this case 540. But screen sizes can and will be different, so this is why we need another local float variable called halfScreen. Inside of it, we're going to store the screen width divided by 2. And we're going to use this variable right away by subtracting it from the mouse position.x, and we'll take the result and divide it by halfScreen as well. I actually made a small mistake here, I used subtraction instead of division. We're gonna fix that shortly, but just be aware of this. Alright, now let's look at a specific example just to explain why we need this equation. In our case, the screen is 1080 pixels wide. In this case, the half-screen variable will be equal to 540. Let's take the specific example where the finger is located right in the middle of the screen, so the X position of the mouse will be 540 as well. If you do the operation with these values, you'll see that we get 0, which is exactly the result that we were looking for. When the finger will be on the left edge of the screen, the X position of the mouse will be 0, so we will get -1. And when the finger is on the right edge, we'll get 1. So everything's working as intended here. Next, we need to assign this X position to our capsule. So for this purpose, let's create a private transform and serialize the field. Now we can take this transform's local position and say that it's equal to a new vector 3. On the X, we're gonna have the X position that we calculated above, and we're gonna have 0 on the Y and Z axis. Finally, I got around to fixing the typo that I mentioned earlier. Now the only thing that's left to do is to go back into Unity, drag the capsule into the player transform field and hit play. Everything works well except two things. First, the capsule clips into the ground, and second, we are limited to a maximum position of 1 and -1 on the x-axis. To fix the first issue, we can simply go back into the code and change the Y position to 1. And after we make this change, the clipping is solved. Regarding the second issue, currently our player is limited to a range between 1 and -1 on the x-axis. But if we would want to move to 1.5 or even 2, we need to add a variable that we can control. So let's just do that. Let's go back into the code and create a new private float called limit value. Let's also serialize it so we can set it from Unity and go into the move player function. In here, we're going to introduce a new float variable called final position, where we are going to multiply the X position that we calculated above with the limit value. Then let's take this new variable and set it as the X coordinate. For this game, I used the value of 1.5, so you can set the same one. And after you press play, you'll see that it works well until you move your cursor out of bounds. Obviously, this can only happen inside the Unity editor, because you can't move your finger out of bounds on a smartphone screen. But let's fix this anyway, just for the sake of being thorough. To achieve this, we're going to clamp the value of the final X position. The minimum will be minus limit value, and the maximum will be limit value itself. That's it, we have a fully functional movement system. The player can move forward and horizontally even on a curved path. And to cap things off, I want to thank all the amazing Patreon supporters for making this video possible and sponsoring the channel. That's it for today, stay safe and keep making games.